Good morning, everyone. Let us start the session. Okay. In the previous lecture session, we had seen how to write microprograms for the four operations, instructions, and branch, store, and exchange, which were given in your textbook. Okay, so now today we'll be solving we'll be writing few more microprograms for a question, which is a very important question. 7.16 of your Morris Mano textbook. We'll be writing few more microprograms so that it becomes easy for you to understand how to write microprograms, and then whichever task would be given to you, you will be easily able to write it. Okay, so let us quickly start off with the first one is AND. Let us see how to write the microprogram for AND. The opcode is 0100 and hence what would be my origin? Two zeros over here, 10 over here, and it would be ORG 16. Okay, 1, 2, 4, 8, 16. So ORG 16. Make a label and then here my operand is in memory. So what did we study that? If you want to access memory, first task is check direct indirect. So no operation, I call indirect. After this is checked, if I is 1, it will fetch your effective address by going into this particular function indirect. And if I is 0, no problem, you already have your effective address in your AR. What would be the next step? Read. What is read? M of AR to DR. You jump next. Once you have your operand in DR, simply use the AND micro operation. So this one is same as your add. Okay, so your AND micro operation, you jump fetch. So first one done. It was easy, similar to your add. Okay, then now let us see the next one. Next is sub 0101. Second given to you is sub. Its opcode is 0101. So what would be the origin? 1, 2, 4, 8, 16. 16 plus 4, 20. So ORG 20. Make the label sub. Again, for sub, I need to fetch the operand from memory. So first thing is no operation. I call indirect. Once you have your effective address, then read. You jump next. And once you have your operand in DR, simply use the micro operation sub. See, sub is already available in your F1, F2, F3 wala pool. Okay, so you can use it directly. No need of complementing and 2's complement, addition, etc. No need to do that. Okay, so once it's done, you jump fetch. So again, this is also done. These two were very simple, like the one which you did for add. Moving to the next one. Your third is ADM. ADM stands for add to memory. The opcode given to you is 0110 और इसमें आपको क्या करना है? In your memory you have to add whatever is your current operand plus AC. Okay, so add to memory, here you have to add the content of AC to memory. Now here again, as you have to access the memory, पहले तो ORG लिख देते हैं. What would be the ORG? 10 over here, 0110 and 2 zeros here. So ORG would be 24. Make the label ADM. Now, you know that as you need to access memory, first line would be no operation, I call indirect.
This meeting is being recorded.
No operation, I call indirect. Okay, next we will do read. See, why did I do read? Because we cannot carry out direct addition operation between AC and memory. So I'll have to first read the content of this memory. I need to fetch this operand to DR. So read operation would transfer the content of M of EA to DR. So read, then you jump next. Now my operand is in DR. I can simply perform the add operation. But here in this question, it was also mentioned that the content of AC should not change unless and until asked. तो इस केस में हमें तो ये करना है. Here, do we need to change the content of AC? No. So what will I have to do? I'll have to first preserve the content of AC. To preserve the content of AC, what we will do is we'll swap AC and DR. Okay, so ACTDR, comma, DRT, AC. You jump next. Now I can carry out the addition operation. So what I'll do is add U jump. अगर मैं इधर next लिखूं, now see addition is done, but my addition wala answer is in AC right now. Where do I need to store it to? Memory. Why? Because your destination here given is memory. So अभी आपका और क्या काम बचा है? Swapping is left out and storing the answer back to memory. 2 steps are left. But if I write next over here, मेरे 4 words are already utilized. Can I use additional words? No, because in the next location I might have microprogram for other instruction, right? So I cannot do that. I'll have to jump to a new location, write the 2 steps over there. But जो 2 steps लिखने थे वो मेरे पास already है. In the one which we had written earlier. Let us see, हमने exchange कल किया था, right? In the yesterday's session we had seen exchange. In that, look over here. Swapping and writing to memory are already done over here. So can I redirect my last line to this particular label? If I make a label over here, L1, can I jump to this location? Instead of making 2 new instructions in my control memory, if I jump to this location, तो मेरा काम हो जाएगा, पहले swap कर दो and whatever is the answer, write it to memory, right? So what we will do is here, either you can jump to L1, कहाँ गया हमारा? Yes, either I can write L1 over here or we can write exchange plus 2. Exchange is at this location, okay? Either jump to exchange plus 2, exchange plus 1 and plus 2. So jump to this location or you can make a new label over here and jump to that particular location. So here we are not utilizing any other extra memory, but we are going to an already existing part of our microprogram. Now in this case, we were already having this exchange part over here. But what if you have not made this exchange earlier? So in that case, start from new org. कहाँ से? Fetch 64 to 67 है, 64, 65, 66, 66 तक. Then indirect is 67, 68. So उसके बाद वाली जगह is खाली for remaining operations, right? So you can start from org 69 and make the 2 lines to AC to DR, DR to AC and write वाला operation over here. Okay, but in this case, we were knowing कि हमने ऊपर आगे बनाया हुआ. So if it is already existing, you can jump to that location. But if it is not, then you can make, or you can utilize the memory, second half of our memory, which is for common functions and for microprograms, which cannot be completed in 4 microwords. Understood? So this is done. Here simply, after redirecting it to exchange plus 2, your program would store your resultant into memory. Memory में write हो जाएगा and AC would be replaced by DR, exchange with DR, so AC will also not be changed. Okay, so first whatever answer was in AC, after you exchange AC and DR, the answer would be in DR. And then when we write operation, the content of DR would be stored to memory. Clear? Chalo, moving to the next one. Okay. After ADM, add to memory, the next one is BTCL. BTCL, clear bit. Let us see how to do that. Okay. The fourth one. The opcode is 0111. Okay. And in this, what you have to do is AC equals to AC and M of EA ka complement. this operation is to be done. Okay, so now let us see. As the opcode is 0111, ORG would be 28. 0 1 1 1, पीछे 2 0, आगे एक 0. So 1 2 4 8 16. 16 plus 8 24 plus 4 28. So ORG 28. Then make the label BTCL. Now again I have to fetch from memory. So what would be my first one? First micro instruction, no operation, I call indirect. Now we will fetch this operand to DR. So for that, read you jump next. Now DR में आ गया, ठीक है? Now again what we will do is I need to complement it. Can I complement DR? No. So the complement function is there, complement micro operation is there, but it complements the content of AC. So what we will do is we'll swap DR and AC. Okay, so DR to AC, AC to DR. Why are we doing this? Because I want to complement, and complement cannot be done on DR. So I'll transfer it to AC. You jump next. Okay, now after doing this, write complement. So now what would we have? Whatever was an AC, that is complemented. You jump. Now can I write next? 4 तो खत्म हो गए, तो अब मुझे कितना काम बचा है? सिर्फ एंड ऑपरेशन इज लेफ्ट आउट. एंड का हमने इधर लिखा था, डू यू रिमेम्बर? एंड यूज किया है. यस, द लास्ट लाइन. इफ आई रीडायरेक्ट माय प्रोग्राम ओवर हियर, यहाँ पे एक लेबल बना देती हूँ L1. ओके, ऊपर L1 बनाया था, लेट अस मेक इट L2. So if I redirect L2 over here, तो मेरा last and वाला task हो जाएगा. So here what I'll do is, in the last line, after complementing, you jump to L2. तो L2 में जाके and हो जाएगा, and then whatever is in my answer, AC and M of EA का complement would be stored to AC. Right? So this is how you are utilizing already written micro instructions in a particular micro program. अगर नहीं है तो as I told you, make a new line, but don't write next. If you write next, you have another microprogram written over here. In this configuration given to us, every microprogram occupies only 4 control words. Okay, I are given only 4 control words. So you cannot write next over here, but make a new label in the second half of your control memory and utilize that space. Is that clear? Okay. Moving to the next one. Fifth one, which is BZ. BZ is what? Branch if AC is 0. The opcode given to you is 1000. Here what you have to do is, if AC is 0, then branch. So transfer the content of EA to PC. Okay. So now let us write a microprogram for it. What is the ORG? 1000 और पीछे 20. So that would be ORG 32. Make the label BZ. If AC is 0, so you don't have to fetch the effective address first. First check the condition. Which condition? 0 wali condition. So what is my first step over here? No operation, Z, jump. Okay. If Z is 1, यानी अगर AC 0 है तो मुझे कुछ करना है. So let us make a label over here named 0. ठीक है. अगर Z की value 1 है तो 0 पे जाओ. But अगर नहीं है तो it is going to go to the next line. The next line में क्या करना है? If Z is not 1, अगर Z 0 है तो क्या करो? No operation, you jump, fetch. Go and fetch the next instruction. I don't want to do anything. Okay, so if AC is 0, I don't want to do anything. AC 0 कब होगा? जब Z 1 होगा तब. But अगर Z 0 हुआ तो मुझे कुछ नहीं करना है. So in that case, it will go to this particular instruction. No operation, you jump, fetch. Go and fetch the next instruction. But what if AC is 0? What if AC is 0? Jump to this label, and in this label what we will do is fetch the effective address. So how to fetch the effective address? No operation, I call indirect, and then transfer the content. Whatever you will be getting in AR. So AR to PC कर दो अब. AR T PC. You jump, fetch. Right? So this is the microprogram for BZ. Clear? I hope you don't have any doubt here now. Okay. Similarly, you can write microprograms for any task given to you. Next is SEQ. Opcode is 1001. What you have to do here, skip if equal. क्या equal check करवाना है? If AC is equal to your memory word, skip करो. Skip यानी PC equals to PC plus 1. Okay? So now let us write for this one, SEQ. 1001. So ORG would be 36. What will we do here? First of all, SEQ. If AC and this are equal. Okay. तो पहले तो effective address fetch करना होगा. So first thing is no operation. I call indirect. Then read. Why? I cannot compare directly AC and M of AC. I'll have to fetch it to DR. Okay. So read, U, jump, fetch. Then now for checking whether these two values are same or not, I can use either subtraction microoperation or XOR microoperation. But if I perform subtraction or XOR, my AC would become 0. My content of AC would change, which I don't want. मुझे तो सिर्फ क्या चेंज करना है, अगर ये दोनों सेम है तो पीसी की वैल्यू चेंज करनी है, राइट? सो व्हाट, टू प्रिजर्व AC, I'll have to first swap DR and AC to DR, DR to AC. Then you jump next. I made a mistake here. This is not fetch, you jump next. Sorry. After doing this, either you can use either of this, subtract या XOR. So what will we do here? Sub, you jump. Subtract करने के बाद मुझे पता चल गया कि AC 0 है कि नहीं, तो मुझे PC equals to PC plus 1 करना है, और ये जो हमने swapping किया था उसको भी वापस सेट करना है. But now if you look over here, 4 control words are done. So what we will do is, अभी मेरे 2-3 steps बाकी है ना, so let us make a label over here, label L3. We will start it from ORG something after your indirect, ORG 69. अब मुझे क्या करना बचा है? Jump to L3. In L3 what we will do is, we will swap, bring AC to its original location. So AC TDR, comma DR to AC, and simultaneously we will check whether the content of Z is 0 or not. Okay, so if Z is 0, तो jump to एक और लेबल बनाना पड़ेगा, equal. Let us make a label called equal. If Z is 1, तो jump to equal. It indicates that subtraction का आंसर आपको 0 मिला. But if Z is 0, it will go to the next line. And in next line what we need to do? कुछ नहीं करना है. No operation. You jump, fetch. Okay. But what if Z is 1? If content of AC is 0, what I have to do is transfer. नहीं, skip करना था ना? Skip करना है, PC को increment करो. So what would be my last line in equal? If it is equal, what I need to do is INC PC. It is also a micro operation already available in your F1, F2, F3 pool. Okay. So in PC, you jump, fetch. Understood? So now this particular microprogram took 4 plus 3. 7 control words. So we cannot write it here as next, but we made a new label L3 and we wrote the 3 control words separately. Okay. Now, chalo, I'm giving you some time. For the last one, BP and Z. You'll be able to do it on your own. The opcode is 1010. Here what you have to do is, if AC greater than 0, then PC equals to effective address. Here we have to check AC greater than 0. What does AC greater than 0 mean? It is not equal to 0 and it is positive. Okay, so here we will have to check 3 things. Z को check करो. अगर Z 1 है, if Z is 1, Okay, पहले तो org लिख दो. What is org? 01010 and 2 zeros. So 1, 2, 4, 8, 16, 32. So org 40. Okay. BPNZ. First thing is check the value of Z. 0 है कि नहीं. Okay. So no operation Z. If Z is 1, if it is 0 तो क्या करना है? कुछ नहीं. Jump fetch. कुछ नहीं करना है तो fetch पे चले जाओ. Go and fetch the next instruction. एक और चीज चेक करो. If it is negative यानी साइन बिट. If S bit is 1 तो भी कुछ नहीं करना है. Jump to fetch. अगर पॉजिटिव, इफ दिस इज नॉट ट्रू, इफ 0 नहीं है और नेगेटिव भी नहीं है, तो मुझे ये काम करना है. तो मुझे इफेक्टिव एड्रेस चाहिए. सो व्हाट वुड बी द नेक्स्ट स्टेप? फेच द इफेक्टिव एड्रेस. नो ऑपरेशन. आई कॉल INDRCT. So now you will have your effective address in EA. Now simply transfer AR to PC. AR to PC. You jump fetch. So this is BZ. BPNZ, sorry. Fine. So this is your 7.16. This is how we write microprograms for any micro instruction, any instruction given to us. Now, if you look at your textbook, you have 7.17 and 7.18. 7.17, I think, is for ISZ instruction, increment and skip if 0. Now you know how to write microprograms. So what you have to do is just first recall the register reference statements that we had studied for ISZ. ISZ में क्या होता है? Just recall those things and then convert it to microprogram. Similarly, 7.18, if you see, is of BSA. BSA was branch and save return address. Okay, so you know what you have to do in branch and save return address, which are the steps involved in BSA from chapter number 5. All you have to do is write it in the form of microprogram. Simple. Okay, so this was it. Few examples which we did for chapter number 7. And only now one topic is left in this chapter, designing of the control memory, which we'll be doing it in the next lecture session. Okay? If you have any doubts, you can ask me or you can leave the meeting.